For decades, we have built massive machines to calculate the machinery of the world. We track billions of data points through endless rows of processors. Yet, if you look at the floor of the New York Stock Exchange, you see a system that defies all that computing power. Millions of dollars change hands in a frenzy that seems completely immune to our algorithms. We have the hardware to simulate galaxies, but we cannot tell you if it will rain 3 weeks from now or exactly where a stock price will close next Tuesday. This failure happens not because our computers are too slow or because we are missing a hidden variable. We fail because of a strict mathematical trap woven into the rules of physics. Mathematicians call this chaos theory. Chaos theory is a branch of mathematics focusing on dynamical systems, where apparent randomness is actually governed by underlying deterministic laws. To see how this trap springs shut, we have to look away from massive global networks. We need to strip reality down to a microscopic, purely theoretical math game. True unpredictability is born in the fine details. To understand why massive data models fail, we have to watch a set of rigid, absolute rules break down at the smallest possible scale. Let me introduce you to the Circle 10 system. It is a perfectly rigid, predictable mathematical machine, consisting of a circle divided into 10 numbered sectors from 0 to 9. The machine operates on 2 simple rules. First, we take the starting point's position and multiply it by 10. This effectively stretches our data, pushing points far apart. Second, because the circle has a strict boundary, we chop off the digit to the left of the decimal. We fold the number and wrap it back into the confines of the original space. Look at what happens when we feed a specific decimal, like 0.37976, into the machine. Applying our 2 rules simply shifts the decimal point 1 spot to the right. The number drops its first digit and becomes a new position. Run the cycle again, and the point shifts right once more. 37976. The itinerary the point takes around the circle perfectly matches the digits of our starting number. If you enter a fraction like 1/2, the decimal expansion is short and finite. The point will quickly settle into a repeating loop, doing the exact same thing forever. Give the machine a simple input, and it gives you a perfectly mapped future. The system runs like clockwork, creating an illusion of total, unshakable order. Now, consider the outcome of a casino roulette wheel. The numbers it generates, 5, 23, 12, 30, form a totally random data sequence. We can take that exact string of random roulette numbers, put a decimal point in front of it, and feed it into our perfectly predictable Circle 10 machine as a starting position. Even though the rules of our machine have not changed, it spits out a trajectory that is observationally identical to pure chance. The point jumps from sector to sector in a completely random sequence. A totally deterministic set of equations is producing genuine randomness. The culprit is the machine's constant stretching and folding process. Stretching forces nearby points apart, while folding forces distant points together, inherently magnifying microscopic details with every cycle. Let's run 2 simulations side by side. We give them identical starting numbers, except for a single error located at the 30th decimal place. That error represents a difference of 1 part in a million trillion trillion. Yet, because the machine shifts the decimal right with every step, it takes exactly 30 cycles for that microscopic error to become the first digit. At step 30, the 2 identical paths violently split apart. In any system governed by stretching and folding, an unimaginably small error in your present measurements guarantees total predictive failure in your future. Earth's atmosphere is a bounded system. Hot air expands and stretches, while the limits of our atmosphere fold that air back onto itself. Global weather is just a much larger version of the Circle 10 machine. The global economy operates the same way. Money expands through compounding interest and credit, and folds back through finite resources and market corrections. Our inability to predict the future is caused by our physical inability to measure the present. We can never know the absolute, infinite precision of every temperature gradient or every financial trade. We will never build a sensor accurate to the million trillion trillionth decimal point. Mathematicians call this limitation pathological sensitivity to initial conditions. Pathological sensitivity to initial conditions is a mathematical property where two nearly identical starting states diverge exponentially over time, rendering long-term forecasting impossible. The future remains unwritten, not because the world is magical or because we lack sufficient data. We cannot predict tomorrow because the foundational mathematics of reality demand that the microscopic will always eventually overwhelm the macroscopic.